Hi, this video is part 4 of a mini-series based on a research paper released by Anthropic in March 2025, a deep dive into how their Claude model actually works on the inside. Using a technique called circuit tracing, the researchers traced the flow of information inside the model as it handled different kinds of tasks, from reasoning to language, math, factual recall, and now refusing harmful requests. This is a big one. If you've ever tried to prompt an AI to do something dangerous or unethical, even as a joke, you've probably seen it push back. It might say, I cannot help with that, or that request goes against my programming. But how does it know when to say no? Where does that refusal behavior live inside the model? And how is it different to the rest of the model's logic? That's exactly what Anthropic's researchers set out to explore. And what they found is that refusal is not a single rule or instruction baked into the model. It's something the model learns during training. Here's what the study shows. During pre-training, the model picks up all sorts of features. Some of those features are related to potentially harmful behavior, things like instructions for violence, hate speech, or illegal actions. These features are learned passively because the model is trying to understand all kinds of language. But later, during the safety fine-tuning, the model is trained not just to generate helpful responses, but to recognize and refuse certain requests. That's where a special circuit comes in. The researchers found evidence that the model creates a general purpose harmful request feature. This feature seems to be aggregated from multiple other features, each representing a specific kind of harmful request it saw during pre-training. For example, there might be one feature related to weapons, another to illegal activities, another to hate speech. And during fine-tuning, the model learns to bundle those together into a broader internal signal which says, this is harmful, say no. In other words, the model is not just memorizing what to avoid. It's generalizing, learning to recognize new harmful requests based on patterns it's seen before. So what does this circuit look like? Using circuit tracing, the researchers were able to map out the path from the input prompt, a harmful instruction, through the activation of these internal harmful request features to the point where the model outputs a refusal. This refusal behavior is measurable. The model doesn't just randomly reject things. It's using a set of internal features, ones that are distinct from the features used for answering questions or recalling facts. And that's important because it shows that refusal is not just part of the output layer, something tracked on at the end. It's deeply embedded in the model's reasoning process. In some cases, the model will even activate refusal features midway through processing a prompt, changing course before it finishes thinking. That brings us to something else the researchers noticed. The harmful request circuit is stronger and more effective in the fine-tuned model than it is in the base model. And that makes sense. Refusal is a behavior that emerges after pre-training, not during. But here's the subtle part. The harmful request feature depends on features from pre-training. The model doesn't invent the idea of harm. It learns it by building on examples it's already seen, and then fine-tunes how to respond. So, to recap, refusal is not hard-coded. It's built on top of features the model learned during pre-training. Those features are combined into a general harmful request signal, and during fine-tuning, the model learns to use that signal to shut down unsafe responses. This has big implications for alignment and safety because it means refusal is not just a filter, it's part of the model's internal logic. And if we want safer models, it's not enough to tweak the output. We need to understand how these refusal circuits are formed, strengthened, and importantly, how they can be bypassed. Which brings us to our final episode, jailbreaks. What happens when someone intentionally tries to break these safety mechanisms? How do models respond to clever, disguised, or indirect harmful prompts? And what does circuit tracing reveal when a model starts answering a dangerous request, but then changes its mind mid-sentence? That's next. See you there.